In this video, we're going to be finding area between curves expressed as functions of y. So we're just going to do two examples, starting with this first one. It says find the area of the region bounded by y squared equals 2x minus 2 and y equals x minus 5. So first thing we need to do is graph so that we get an idea of what the region looks like. So first thing I'm going to do is we have this y squared equals 2x minus 2. We're used to having y isolated, so if I square root both sides of the equation, I get plus or minus the square root of 2x minus 2. And we should know that this is going to look like a sideways parabola. And then I have the line y equals x minus 5. Let's find our points of intersection. So I'm going to set the two equations equal to each other. We have x minus 5 equals, I'm just going to do the positive to start out, positive rad 2x minus 2. I'm going to square both sides. Squaring both sides would get rid of that plus or minus anyway. So on the left side, when I square, let's write it like this. I get x squared minus 10x plus 25 equals 2x minus 2. Let's get everything on one side. Oops. And factor. When I factor this, I get x minus 9 and x minus 3. So that means for my points of intersection, I have an x value of 9 and I have an x value of 3. To get the y values, I can plug the 9 and the 3 into either of my two equations. I would say that x minus 5 is probably easier. So plug in for x, 9 minus 5 is 4. 3 minus 5 is negative 2. So these are my 2 points of intersection. I'm just going to say 9 is right here and 3 is right here. And then another thing to point out is I can tell with this equation, we could set it equal to 0 if we wanted, but notice if I plug in 1 for x, 2 minus 2 is 0, so the point 1, 0 is on this y squared equals 2x minus 2 equation. So I know my sideways parabola is going to go through 1, 0. And then let's graph the rest. I'm going to say 4 is right here. So here's 9, 4. And then I'm going to say negative 2 is right there. So here is my parabola. And then let's also graph our line. So that means the region that I want to find the area of is this one right here. And we want the area of the region bounded by those two graphs. So that's why we know that this is the area. Now that we have a picture of our region, let's come up with a game plan for how we're going to find this area. In the previous video, we did functions in terms of x, so we had vertical rectangles. But I want you to notice if I draw a vertical rectangle, at this part where my rectangle is, my top function is my rad 2x minus 2. My bottom function is the x minus 5. But if I draw a rectangle right here, my top function is the rad 2x minus 2. The bottom function is the negative rad 2x minus 2. So because the top and bottom functions change as you sweep this rectangle left to right, we would have to separate this into two separate regions. So I would have region 1 and region 2. Now it's doable, but we would have two separate integrals and it would just be more work. I want you to notice, let's backtrack a little bit. If I draw a horizontal rectangle, notice that my right function is always going to be the line and my left function is always going to be that parabola. So in this case, it is easier to use horizontal rectangles. So let's talk about how we do this. Now, for horizontal rectangles, we are going to say that the height of this rectangle is delta y, and we need to figure out the width of the rectangle. And for that, we need to rewrite our two equations to be in terms of y. So I'm going to take my two equations and I'm going to solve for x in each case. So I have y equals x minus 5, and I have y squared equals 2x minus 2. So for this first one, I'm going to add 5 to both sides. We get x equals y plus 5. So this is x equals y plus 5. For the second one, I'm going to add 2 on both sides, divide by 2 on both sides, and we get that x equals 1/2 y squared plus 1. Now, when we had our vertical rectangles, we said that the height of the rectangle was always the top minus the bottom. For this one, we need to figure out the width of the rectangle. And we're going to say the width of the rectangle is always the right minus the left. And if we put numbers on it, let's just say that for this particular rectangle, where this rectangle is, let's say this is at, I don't know, 5, and this one is at 3. To get the width of the rectangle, you're going to do the right minus the left, 5 minus 3. So that's why this works. So we're going to do right minus left, but instead of having numbers, we have our two equations. So my right equation is this y plus 5. So I'm going to start with my y plus 5. My left equation is the 1/2 y squared plus 1. And I want you to, well, my left equation is the 1/2 y squared plus 1. Now that we have that, let's set up our integral. So my area is going to be the integral. Now all of this is in terms of y. So I want you to imagine taking this rectangle and sweeping it vertically. So I'm going to start down here. We decided this is at the point 3, -2. So I'm going all the way down to -2. That's where I'm starting. So that's going to be the lower bound of my integral. And I'm sweeping this rectangle all the way up to this point, which is at 9,4. So I want to integrate. We're integrating in terms of y, and I'm sweeping this rectangle from -2 to 4. So those are the bounds of my integral. And then I'm going to integrate my area of my rectangle. So I have my width, which is our y plus 5 minus 1/2 y squared plus 1. And then this delta y right here turns into our dy. And this is our integral that we have set up. Okay, so now that we have our integral, the rest of this problem is solving our definite integral. So I'm going to start by simplifying a little bit. Let's see, we're going to distribute the negative, so I'm going to have minus 1/2 y squared minus 1. So this is going to be y plus 4 minus 1/2 y squared. And let's do our integral. I'm going to have 1/2 y squared plus 4y minus, this is going to be y cubed. 1/3 times 1/2 is 1/6. And let's plug in. I have 1/2. 4 squared is 16, plus 4 times 4 is 16, minus 1/6. 4 cubed is 64. Minus, let's move this down. Plug in the -2. 1/2 -2 squared is 4, minus 8 minus, that's going to be a plus 1/6 times 8. And when we simplify, we are going to get 8 plus 16 minus 64/6 is going to be 32/3. Minus 4 times 1/2 is 2, plus 8, minus 8/6 is going to be 4/3. And this is going to be 8 plus 16 is 24. -2 plus 8 is plus 6. This is going to be these two together, negative 36 over 3, which is negative 12. So 24 plus 6 is 30. 30 minus 12 is 18. So a lot of arithmetic at the end, but this is our first example. And then maybe we should put units squared because it's area. We have one more example. Number 2 says find the area of the region bounded by y equals the square root of x, y equals 0, and y equals x minus 2. So first thing I want to point out is we could still solve this using vertical rectangles. But because my top and my bottom change at this x equals 2, same issue as the last one, we would have to have two separate regions, which means two separate integrals. Again, we could do that, but notice that it's easier if we do horizontal rectangles. And the reason why it's easier is because our right equation is always going to be the line x minus 2, and our left equation is always going to be this square root of x. So we're only going to need one integral. So let's go through our steps. I want to rewrite my functions in terms of x. In terms of y, I want to solve for x. So I have y equals the square root of x, y equals x plus x minus 2. I want to square both sides. So this is x equals y squared, and this is x equals y plus 2. So my width of my rectangle is always my right minus left. That's going to be y plus 2 minus y squared. So this is negative y squared plus y plus 2. And when we integrate in terms of y, I want my y values. So this is the point 2, 0. So I'm going to integrate from y equals 0 to y equals 2. And I have my width, and the height of my rectangle is this delta y, so just reminds us that we are integrating in terms of y. Let's go through and solve this integral. So I'm going to get negative 1/3 y cubed plus 1/2 y squared plus 2y. And that's from 0 to 2. Plug in. 2 cubed is 8, plus 1/2, 2 squared is 4, plus 2 times 2 is 4, minus, notice when you plug in 0, all of these terms are going to equal 0. So I just have minus 0. So this is going to be negative 8/3 plus 4 times 1/2 is 2, plus 4. This is negative 8/3 plus 6, which is negative 8/3 plus 18 over 3, getting common denominators, which is 10/3 units squared. And that is our second example. Thank you for watching this video.